Okay. Hello, everyone. Thank you for coming to the last Tocker today. My name is Morgan. I work for Oracle on MySQL. Just before we get started, this is Oracle's safe harbor statement. It basically says that if I talk about upcoming features, I have a couple of slides on MySQL 5.7. I can't commit to dates, can't commit to things might change slightly. At Oracle, I showed this slide yesterday as well. We're celebrating our 4th birthday. Being the steward of MySQL, we celebrated this last month. Some interesting things that we managed to do in that time is release MySQL 5.5, a lot of improvements for InnoDB and scaling MySQL on multi-core machines. There's a lot of talk of scale out, but scale up is also very important because it's the easiest way to be able to retrofit performance to an application. So I like that aspect. MySQL 5.6 has a lot of stuff. So much stuff, in fact, that I chose not to specifically talk about MySQL 5.6, but one aspect of that, and that's how it's easier for operations people to be able to use now. Something I care about a lot. Previously doing consulting, I worked for a company, Pecona, that runs MySQL Performance Blog. There needs to be a huge focus on databases in how to manage them and get performance. Often you'll find that someone has a performance problem and they're not really getting the performance that they're entitled to because they don't have the visibility to see that. And so I want to focus a lot on that, which is the diagnostic enhancements that we have in MySQL 5.6 and some other features that make it easier if you're a DBA, a DevOps person, or somewhere in between. I'll give a quick introduction to MySQL 5.6 as well, and our development model, but it won't be my main focus. So with that quick introduction, let me tell you about MySQL's development model and how we develop each new release of MySQL. At the moment, as I said, we're working on MySQL 5.7. MySQL 5.6, it was GA'd in February 2013. So under Oracle, the way that MySQL releases happens has changed. What we do is up to 4 times per year, we release what we call a DMR, or Development Milestone Release. And this is intended to have new features that have been high-level reviewed in how you interact with them, low-level reviewed into how the architecture and code works, and tested with 80% plus code coverage. They're somewhat stable. We aim for them to be about a release candidate. And we release up to 4 of these per year, as I said, with new features. And this is your opportunity to be able to test them and see what's going to be happening next. We roll up these development milestones every 2 to 3 years, and then we make a major release. So it took 2 years and a couple of months between MySQL 5.5 and MySQL 5.6 for this release to happen. This is going to be quite predictable moving forward based on this development model. Everything must be tested, everything must work first before it's sort of merged into trunk, I guess as you might call it as a developer. So we started off with optimizer enhancements, InnoDB enhancements. Later on, more optimizer, more InnoDB. It's very agile in that when we set out with our plans of what we're aiming for in MySQL 5.6, we'll get hopefully most of them done, but we might change some of those plans, and we're able to react to market needs if other features work out being more desirable or more important to be able to integrate. So 5.6, I said it has a lot of stuff. By lines of code, there was actually this interesting analysis by a guy named Stuart Smith, now works for IBM. I love his quote. He's Australian like me, so he's got this sort of sarcastic sense of humor. He said, MySQL 5.6 is the largest MySQL code size increase in a MySQL version ever. Last time we saw this, with MySQL cluster integrating. Most importantly, Oracle is paying people to write lines of code to the extent that nobody has before. I assure you there's features as well, but we're writing a lot of code. If you see the difference between, it's not so visible, MySQL 5 and MySQL 5.6, the code size of MySQL has increased. The version numbers don't tell the full story. And if you look at the delta, there's quite a lot of stuff that came in. And some of these are they're quite core infrastructure changes that happen. So I also didn't want to try and read off bullet points because it can be kind of boring. I wanted to focus on these operational enhancements. But we fixed a lot of bugs as well in our 4 years and in our period leading up to MySQL 5.6. 2,000 bugs fixed, 4,000 bugs in total fixed since MySQL 5.5. The quality of the product is much better. By major features that were advertised for MySQL 5.6, I said there's a lot of things. These are the ones that I looked on our public website and I said, what are we advertising that we did? They look pretty cool, I think. What did we actually do, though? I pulled this from a MySQL performance blog post. This is what we did. So I don't think that's going to be readable. I just wanted to show you, there's a lot of goodies. I will try and put that slide up at the end of my talk, and if we have time, try and discuss them. I don't know if probably the first row can read them. Probably no one else past that can. So that's my introduction. Let's get on to the operational enhancements, and then after that, we'll cover diagnostics. So number one, best reason for a lot of people that they've given the feedback to upgrade to MySQL 5.6 is we now have online DDL for a number of operations. This means that when you create an index, when you drop an index, or a few other operations, it doesn't block readers, it doesn't block writers. Your application continues to be online and fully operational. What people used to do is they used to add the index on the slave, and they used to try and do the switching to make the slave the master after the index was added, and relied on how replication works. You don't have to do that anymore. You can just add the index. And for the most part, there'll be a little bit of a degradation of services that consume some I/O, but it'll work, and this is very useful. I think this was a major pain point for a lot of people that had large databases. And there was some progression that led to this. In the beginning, actually, anytime you added an index, it used to have to create the whole table again with all the new index definitions and then trickle load the table row by row. It got better in MySQL 5.5, actually, where if you just create an index, it only had to load that index, and it sorted the data before I loaded it. But it's completely good now with MySQL 5.6 that can do that in the background and not impact your clients as they're reading and writing. So I gave the example with indexes, and I said online DDL for indexes. There's a lot of other operations that you will want to do, like add columns, remove columns, or etc. I like how well documented it is in our manual. I have the link to it at the bottom when you get my slides. Exactly which is completely online and does not block readers or does not block writers. The most important column here that does not block readers and does not block writers is this third column in, which says allows concurrent DML. I copied this verbatim from the manual, so there was no other easy way to fit it on the slide, but you can see that a fair number of the operations, not quite all, so if you change a data type of a column or you drop a primary key or add another primary key or convert character sets, these are going to be blocking. But a fairly good number of operations are now not blocking, as you have to make these in production. Oracle cares about how you use MySQL in production. And what I also like about when this feature was introduced, we had another feature where you could, in your alter table definition, specify this additional syntax to say lock equals none or algorithm equals in place. And what this means is that if it's not able to do this not blocking reads or writes, it'll actually refuse the statement from running. So you don't have to play this guessing game. Am I going to have downtime now or not? And I've seen that at least in the Ruby on Rails community with migrations, they've got gems that integrate with this, and by default, as you try and do schema migrations, it will refuse if it can't do it online, and I think that's really nice to care for this operational aspect. I don't know what's happening in other communities yet. Okay, another feature that's very nice, buffer pool dump and restore. So if you have a big server, and let's say that the big server has hard drives in it, and you say that this big server has 64 gig of RAM, 128 gig of RAM, not that expensive these days actually to get a server that has that much. If you were to lose power or you were to do a restart of the server, everything that's stored in the buffer pool in memory, it's going to be lost. And when you restart, you're going to have cold caches. And cold caches, for some applications, if they have very high transactional throughput, means the application is effectively offline. So as we care about operational aspects of MySQL, we introduced this feature where you could save the memory addresses, not the actual data pages, but the addresses, which is a much smaller representation of what was in memory while the server was running, either explicitly by running a command, or it shut down and it could save those addresses for you. And then at startup, it can reload those pages back into memory. So it's only recording the addresses, not the actual content. So if there has been a change, it's not like you're going to get stale data. Storing the addresses is 8 bytes for every 16 kilobytes. So it's quite small, and this is quite useful if you have to do scheduled maintenance and then you want to return to be able to have operational efficiency. You could use this buffer pool save feature as well to initialize a new slave that you're about to fail over. If it had the data originate from the same master, it can be very useful. Did I see a question? I saw it out of the corner of my hand. No, corner of my eye. Okay, another thing that's useful is that when you have InnoDB tables, previously, if you had InnoDB file per table, you could not just copy that mytable.ibd file and restore it on another server. The reason why you couldn't is that it always had some information stored globally in that ibdata1 file, the data dictionary and some undo information. Now what we do is we offer, sorry, am I reading the right side? No, I was reading the wrong slide, sorry. This feature, what it does is it allows you to exchange a petition with a table. So you have a table petitioned, which is a very common data warehousing-like technique, where it looks like it's one table, but it's actually many tables underneath. Let's say that you wanted to archive out some data from one petition. You can swap that with another table that's sitting somewhere else. And this is very useful as a feature with archiving like time series data, or some server that you want to initialize somewhere else that has a smaller amount of disk space, or seeding something. It's very useful that these petitions can now be swapped around. The feature that I was describing, before is that yes, you can switch around the tables that are mytable.ibd from one server to another server by doing this export command and then importing the table space back in. So this is one of the complaints that I know was common for some people like hosting providers that preferred MyISAM to InnoDB because it was very easy to restore a user's data from one server to another. It's now easier to be able to do that with InnoDB. Because if you're doing MySQL dump or something like that, it does take a lot longer to be able to restore it than just the speed of copying data, as it would be close to in this case. A question? If we have someone run with a mic. Excellent.
Does it take the table offline?
Does it take the table offline? I have not tried. I will assume that it might, because it might have to make sure that no changes to data dictionary and stuff are made. I can find you a better answer on that afterwards, perhaps. It does take the table offline in the case of MyISAM. And in this case, we're kind of looking for offering some feature parity, so I don't know if we would have made it online in the case of InnoDB. Another useful thing that's fixed in MySQL 5.6 that makes ops people's life easier is if you have to do a simple thing like change the size of the InnoDB log file. What used to happen is when you try and restart MySQL, it would say, sorry, can't do that. MySQL refuses to start. You've changed the log file size, and I didn't like that. And you had to do this ugly thing where you make sure it shuts down safely, you change the setting and configuration, you delete the log files, and you start back up. Now it realizes that you've just changed the setting, and it expands the size of the log files. And I think that's important for usability, because a lot of people get trapped by this. Even if you're experienced, you'll forget a step. Two more features, both in the replication category. Replication has global transaction IDs now. So if you're running a replication topology where you've got either a master and a couple of slaves, or a master, slave, slave, in some sort of tier, if you have to change that topology order, the coordinates for the binary logs, which is the files used for replications, used to be local to an instance. Now you have this feature where you can make them global, so that if you need to reposition a slave to another slave, it'll just fall into place without having to do some silly math to figure out exactly how to do it. And these are the most stressful situations when you're doing ops things and trying to rebalance things. It's very useful, this feature. And replication is also enhanced because it's now multi-threaded on a per schema basis. So what used to happen is you would have a master and it would have multi-disks and multi-CPUs, and it would be able to exploit all of this concurrency as applications would write to it in many threads. But then it would serialize these writes through a straw to a slave that would be just as powerful, but it wouldn't be able to exploit this parallelism. And it could create a major bottleneck for a lot of people that had a workload that was write heavy. And now it's parallel on a per schema basis. In MySQL 5.7, we've committed that it will be parallel on an intra-schema basis. So replication slaves will be a lot more useful, and they'll keep up with not replication lag. Who's experienced the replication lag problem? I think that's totally, you know exactly what I'm talking about. It's going to be awesome in 5.7. So that was the operational enhancements. In terms of feature sets, let's talk in terms of diagnostics. And I said my bias, I think that diagnostics are awesome because you don't always get the performance you're entitled to. So if you wanted to find out why a query was slow, you might run explain. How do you run explain from your programs and then pass it? It's kind of a silly format in a way, in this tabulated with extra things that turn on. Now we have an option to be able to get explain format equals JSON. And we're expecting applications to be able to use this so they can plug in and find all diagnostics about queries performing slow and etc. When you run explain format equals JSON, I think it's much easier to read, and it actually does include some additional information in it. So I've started reading JSON output for explain instead of reading tabular output for explain, and I think it's very useful. At the back of my slide deck, I have a visualization that actually our tool, MySQL Workbench, can read this information and print it out to you in a visual form. Prior to MySQL 5.6, when you ran explain, you could only explain a select statement. Now you can explain update and delete statements and find out if these queries are efficient. And this is very useful. You could rewrite your update or your delete statements to selects, and then you could explain them, and this would be roughly equivalent. But it's much nicer if you want to do things in an automated way to be able to explain the update or the delete directly. So I said that explain format equals JSON is nice. There's one even more detailed called optimize a trace, where it can give you sort of the same information as what explain does, but a whole lot more. Typically, it's like, on any query of any detail, it's like 0.5 MB of data. It'll tell you not just which query or which index was picked, it'll tell you why the other ones weren't picked. And it'll show you some transformations that happen where it can do, what it calls equality propagation, where you say if A equals B, and B equals C, then A equals C. It'll show you how it's making these optimizations. We actually created this feature so that it would be easier for our optimizer team to be able to ask people for bug reports. But it's incredibly verbose, and it's actually, I don't think it's that hard to read. It's very useful. And so I look forward to seeing more people include this in their diagnostic tools to be able to see why queries are slow. It helps us a lot because our focus, or one of our focuses, is making MySQL's optimizer a lot better and being able to understand things like the difference between hard drives and SSDs. And so having this diagnostic information allows us to move forward at a much faster rate. So the other big, or the big performance change that was made in MySQL 5.6 for diagnostics is this thing called performance schema. So when you used to want to tune your server and say, is it behaving efficiently, what you may have done is ran a command like show global status and show InnoDB status, as some tuner scripts will do, and then they'll make some recommendations. You can still do this, and it still kind of works. I don't think it always completely works, because I think sometimes you're looking for correlation more than you're looking for cause. If I wanted to take a more cynical view of it, it's kind of like when you look at tea leaves and then you try and make a decision. Like sometimes you can see how that might be whatever, but you can never quite be sure. And I think in the new way, it's a lot easier to be sure. And you don't have always a chance to experiment with things in production, so it's useful to have that level of detail. So an example of this in the old way, if you ran show global status, you could see some ratio between temp tables in memory versus temp tables in disk. Well, what's a ratio? A ratio is not so important to me. I think a rate is more important. Like if I was doing everything all in memory, I could do 40,000 queries per second on basically any server, I think, if they're simple queries. And if I had 99% of these queries work in memory, I could be down to like 2,000 or 5,000 queries per second. Because it depends on the rate of what that translates to, of how many IOs it does on disk, and I might have like a single hard drive or something like that. Rate is more important than ratio, and some of these show global status tools, the information is just not detailed enough to be able to tell all this information. It'll tell me as well that it creates a temp table on disk, but it won't tell me how many rows are in this temp table. It could be very small, it could be 1 million rows. It's not query-oriented, so I can kind of use this information to be able to improve maybe the capacity of the server, but I can't guarantee that that translates to a response time improvement to my clients, because it's a little bit too disconnected. So I might be trying to optimize some things, but it turns out that they're only used as part of background queries or reports, and it doesn't matter because there's not a user sitting in front. My last complaint about these old tools is that they're difficult for tooling to be able to plug in. Like this is the output of the command show engine InnoDB status. What do these two numbers mean next to each other? What does this number here mean, or this number here? Like it's not necessarily clear, and sometimes the output is a little bit different depending on what situation happened. It's like conditionally displayed for information. Now, with performance schema, the new way of giving diagnostic information out is to present it as a series of tables or a series of views in this schema called performance schema. And it's similar to how other databases work. It's similar to how Oracle has this wait interface, where it just gives you all this metadata, and at any point in time, if your queries are blocked waiting on something, you can run a select query and you can find out why and where that is. And so MySQL is doing the same thing. So it was actually introduced as a feature in MySQL 5.5, but it was off by default. With MySQL 5.6, it was turned on, and it has some more information that's useful. So I'll have some examples in just a second. Performance schema, the important parts of it is that it's on by default. It has probes on instrumentation points, and you can actually choose which levels of collection it does. so that you can reduce the overhead that applies. And our default collection aim is for less than 5% overhead, but you can instrument some additional things and it might be a little bit higher. Or you can turn some off and it might be a little bit lower. So we have this variable level of configuration that's dynamic. You can turn things on and off while the server is running. Fixed memory by design, designed to be as little overhead as possible. When it was introduced in 5.5, it was off, and it was mainly developer-oriented, that it instrumented things like any file I/O operation, locking things that happened inside the server. It didn't break it down to the query level, but when it came to MySQL 5.6, queries were instrumented, network I/O was instrumented. There was a complete breakdown of time. So if you used a client to be able to connect to a MySQL server and you said use performance schema, in MySQL 5.6, here is the set of tables or views that you would see. There's a lot of them. And it's a little bit hard to know how to write your own queries, but there are packages out there, one called PS Helper, which is a series of views that can sit on top of performance schema. On my next slides, I'll have some examples for performance schema, and some will be custom queries accessing these tables directly, and some will be views that will access these tables for you, if that makes sense. So the audience here is a little bit the tools developers, or a little bit if you know about specific problems you might research and find out how to write a specific query. But everything that's blocking or waiting, it's going to be instrumented in performance schema, and there'll be new features added to this moving forward in MySQL 5.7. So I have, I think, 8 examples. Here is an example where a colleague of mine, he wanted to know how idle connections were by particular users, because he had this one application, hypothetically, that always left transactions open, or had connections that just didn't do anything. So he wrote a query, and he used the information that's available in an events weights summary table in performance schema, and he said that for this particular user, it was 99% idle. For this other user, it was 100% idle, and here was the time that they were idle. Could be useful. If you run the command show process list, it includes which connections are running, but it doesn't say, for example, what interface someone is connected to, whether it be IPv4, IPv6, or if it was a Unix socket connection. And maybe as part of your debugging, this might be useful. I'm not sure. And so here's an example of running a query where you can re-implement the same information and just add an extra column called IPv6. Not that useful. This one's useful, though. This is cool. This is another version of process list. And what it can show you is it can say the users, what they're currently doing, where they're blocked on in InnoDB code. You can see the last statement, how long it took, how much time they've spent in locking, how many temp tables they've created. This is really useful information. And it's just crazy that you can run an SQL query, the same language that you use for your applications, be able to get this data back. You could get a lot of intelligence from this. Anyone ever seen the error log where it says that some connection failed to close? Do you want to know which connection it is? Write a performance schema query. This will tell you by percentage and which user failed to be able to close that connection. So you can see here that there's quite a lot of things that you can potentially do. Last week, somebody was telling me that they were using MySQL as part of their continuous integration tests. Okay, great. They told me that their tests took half an hour. Not so good. I heard it's better to aim for about 5 minutes, seems to be the magic number. And they said, I'm thinking maybe I should switch it to TempFS, and then I'll get better performance and my tests will run faster. And I said, I don't know, probably. I mean, if you're just doing selects or something, when the data's in memory, they're not going to be any faster. But if you're very write-heavy, then yeah, maybe it might be faster. But I was making a hypothesis here, and you don't have to do that anymore. You can actually tell. So I said to this user, Well, we know that TempFS, the aim of it is that we're going to make writes much faster because we're hoping that they're just going to be like memory, right? So I said, why don't you run your tests, and after you've run your tests, we'll just do a performance schema query, and we'll say how much time are we waiting on I/O. Because if we know that the whole set of tests takes half an hour, and then we know the portion of time that's spent on I/O because we can run this query, then we can figure out if this is a large percentage of half an hour and if it would be worth it. You can totally do this, no problem at all. I think it took me a good 10 minutes to write that query. And I think it would have been harder, maybe not much harder in this case, but to switch to TempFS and then see if it was worthwhile. When I talked about this with actually a colleague of mine inside MySQL, who is the maintainer of PS Helper, that set of views that I alluded to earlier, he said, oh yeah, we do that actually as part of the MySQL Enterprise Monitor team. We use MySQL and we use CI and we switched to TempFS. He said, actually PS Helper, it has a feature so that you can get a summary of time for where all time was spent. So I would suggest back to that person that asked me that question that this would be really helpful to include in any CI run, to know that information, know where to make optimizations. In the case of the colleague that I spoke to, he said that he cut his time down from 40 minutes to something like 14 minutes. And a big thing that motivated him knowing that that change was worthwhile is being able to see it in performance schema. So 2 more examples. If you ever want to know how useful or non-useful indexes are, index statistics are part of performance schema, so you could find unused indexes and you could remove them. On the same note, you could find used indexes and see how many rows have happened and how much time has been spent reading from them. And if you wanted to know which statements are slow, you're probably familiar with MySQL's slow query log. This is also available in performance schema, so that if you just logged into a fresh server and you wanted to know what's running and what's been slow recently, this data is already going to be sitting there by default, and you can very easily run a query on it. And here's a quick aggregation that PS Helper has offered me, where it says the query, and it matches the patterns where there could be slight variations to this query. Is it a full table scan or not? How many times has it been executed? How much time in aggregate has that taken? What's the average? I think this is very good for a short play of data, and you might still use the slow query log if you want to analyze a larger period of data. I still use them both. But it's great. That's PS Helper. The examples that I showed here, some were direct to performance schema, some used this package, PS Helper, and some actually I took from a colleague of mine's blog. Any questions on that one? Yeah, we'll wait for Mike.
I actually have 2 questions.
Sure.
One, if it's turned on by default, and the second is, do you have any benchmark how much this affects performances, the performance schema itself?
Sure. So is it turned on by default? Yes, although the instrumentation is tunable, what it'll actually measure. Our aim is to keep the overhead as less than 5%. There are some cases where it might be closer to 10%, and I know in some of those cases we've been working on reducing that for 5.7. That was both of your questions I just answered. Okay.
Thank you.
Yeah.
So that data in those statistics tables, does it get rotated in any way, or is it there as in from the beginning of time, or does it get rotated basically?
Yeah, so it uses a fixed memory buffer, a circular buffer that's pre-allocated, and it actually keeps a lot of the data in the connection threads themselves, and it's when you run a query that it will aggregate it. There's different PS tables, so there's different ways that works. but it is fixed in length and it's a circular buffer and it will get written over. There's some configuration around that. I've not tried to change it from what is its default. You can also truncate the metrics and then start collecting again, which might be useful in the case that I showed with the test suite. Yeah.
In Explain, I often see it's going to use a template table. I
Yes.
would like to predict if this template table is going to be in memory or if it has to end up on a hard drive.
So the simple answer to that is that we can't tell yet. We actually might be able to tell theoretically in some situations if it's got text or blobs, but we can't tell yet for the other situations if it's going to spill over, because Explain is about our ideas in building a plan. It's not about what actually happened. The same with some limits. We can't show you if that's going to be applied or not efficiently, if it's going to find the 5 rows it needs straight away or exhaustively search and not find 5. Yeah. Hope that that answers, but you could use your performance schema data to find out exactly if it had to create that or not.
In retrospect.
In retrospect, yeah.
If you're running a cluster of servers, I assume there wouldn't be any problem having this enabled on one of the write servers and one of the slaves, and not everything, or does it need to be enabled on everything if you run a cluster?
You could run it on one and not the others. Yeah, what I like about this being enabled, and it's kind of like, you know how in the PHP world you've got Xdebug, and that's like a debugger for development? And you can't run that in production, which is a shame, but you only get problems in production, or you shouldn't run in production. But then you've got something like XHProf, which is like a debugger or a profiler designed specifically for production. This is that on the MySQL side. We want you to be able to run it, and our commitment is that we're trying to, in the default configuration, get it to less than 5% of the time so that you'll be able to find these performance problems. Does that answer your question? Yes, you can get what you want, but no, we don't necessarily want you to have to do that. Okay. So performance schema is for our rapidly changing data. It's this view into that internal operations of what's happening. Information schema is similar to that, but this is another database or schema. And it shows the more static data. And it actually predates performance schema. So this came out, I think, in MySQL 5.0, where it's actually an SQL standards thing to be able to show all metadata for the server. It got a lot better in MySQL 5.6. There was the addition of these information schema tables. Mostly in ODB. Yeah, which is cool. So I ran an example, and I wanted to know that I had a server. It had 128 meg as the buffer pool size in ODB's main cache, and I wanted to know if this was a good number or if I had to buy more RAM. So actually, in database principles, there's this thing called the 5-minute rule, which says that if you load a page, the basic unit of space, into memory, if you're going to need that again within the next 5 minutes, you should be able to retain that in memory, and it should not have to be paged out and then reloaded back in. So this is a good way of being able to, it's a rule of thumb, it's not fixed in space, but this is a good way to be able to tell if I have enough memory, if I have the ability to get these diagnostics from the server. And in fact, I do, because I have all of the information about which InnoDB pages are currently in memory. So what I did is I wrote a query, or I wrote a stored procedure, and I said every 5 or 10 seconds, every 10 seconds, it was something I wrote myself, 30 times, see which pages are in memory, the distinct pages. And then after you've run that 30 times, then tell me the distinct count of pages that were required. So what's my working set, essentially? What did I need over 5 minutes? And when I ran this on my server that was doing stuff, it told me that I had a need for 100,000 pages. And that corresponded to 1.5 gig of RAM. And I only had 128 megabytes of RAM dedicated to an ODB, so I knew that I was underperforming. You haven't been able to do this before efficiently. You might be able to tell it from IOStat, kind of. But it's really good to be able to have these diagnostics built into the server. It's like X-ray vision, that visibility that you get. Everything becomes easy when the data's there. So that's mostly it. Just a quick glimpse into the future. Performance schema is going to get better in MySQL 5.7. Transactions are going to be instrumented, and memory allocation is going to be instrumented as well. Both, I think, not by default. You'll have to enable that, and then overhead might just be a little bit higher. There's going to be more explain enhancements. You can explain a running query in another connection. You can show the cost information in explain format equals JSON, which is the optimizer's internal language for how it figures out which order to join things on. And there's going to be more usability in replication where you can online, through some SQL-like commands, change your replication filters as things go to slaves. And you can configure the verbosity of the error log, so what data will get written to, where you can be kind of like very verbose or not very verbose. It'll be a lot more configurable. Some annoying bugs that are long-standing with MySQL, like you could easily create a duplicate index, which is completely redundant. It'll now give you a warning when you do that and say, you won't even be able to do this in a future version, we're going to deprecate it. And when you say Control-C on the command line client, it'll just clear the buffer rather than quitting the program. It's pretty cool. I love that there's a focus on these features. So I said there's memory statistics in performance schema. So I could tell in 5.7 which user is consuming what memory. Very popular request of hosting companies. And I said that the explain format equals JSON is designed for programs to be able to pass that information. And in 5.7 we have cost information, where we say, you know, in our internal math, how expensive we think things are going to be. So this is MySQL Workbench 6.1, I think it's either alpha or beta, connected to a MySQL 5.7 server, and explaining a query that's about to run. Really, really helpful. So that's it. So I'll ask for questions, and I'll also try and answer any of these questions if anyone can read them.
Can you think of a way, information schema or whatnot, that it can more or less measure the impact of my foreign key constraints?
Yeah, I totally think you can do it. I don't have an example off the top of my head, but I think that is instrumented, because you can get the lock time for an ODB from performance schema, no problem at all. I know you asked me that yesterday, but we'll follow up via email, and I'll probably write a blog post. I totally think you could do it. And you could use that proof. And you could say, you know, our queries, when they're waiting on foreign key constraints, they're a lot more variable. They take a lot more time. And we can see total server time over the last 30 minutes is blocked this long on foreign key constraints, and thus we should maybe drop them. Have a little bit more relaxed consistency. Yeah, I'm pretty sure that all that data is available. No problem at all. Do you want me to hold one? Oh, the other thing to mention is that I've got stickers. I forgot to say that yesterday, MySQL, so come up at the end and grab one.
Is there any improvement in the caching invalidation, and caching the queries and the caching part?
So we have a query cache feature, if that's your question, and there's no improvements to that with 5.6.
So the same thing as before.
That's right. Yeah, in terms of like the buffer pool, which is in ODB's page cache, there were some improvements in MySQL 5.5 where it improved its algorithm of if you did a table scan, it didn't evict pages from the cache that were important for like more transaction processing queries. But nothing on the query cache.
Thank you.
You mentioned a performance schema was disabled in 5.5 but
That's
enabled
right.
in 5.6. Is it fine to run it in 5.5 or are there performance worries?
Well, 5.5 as well, the audience was more developers because it said things like locking and file I/O time, and I think one other thing, it wasn't instrumented per query, and I think that's really important. So you're fine to do it. The overhead actually was a little bit higher in 5.5. We managed to tune that down in 5.6, but it won't be as useful as 5.6 is. I think it's just leaps and bounds better.
Thanks.
When you upgrade to the new version, how do you handle slaves now that you're changing the replication?
GTIDs?
Yeah.
Yeah. So the GTIDs isn't enabled by default. So those switching to use GTIDs, generally what I've seen people do is they upgrade to 5.6 across the board, and then they change to use GTIDs or take advantage of newer features. Cool. So this is about 75 new other things to find. It's like an Easter hunt. This is a blog post that was done by MySQL Performance Blog. Very nice to see that level of detail. Cool. Well, thank you, everyone.